Okay, we wanted to welcome you to our webinar today. We're excited to have you again for another webinar. These, if you haven't been able to tell the pattern we're following yet, they're happening once a month. We choose a line of products that we want to talk about, and hopefully you can see the pattern. We're really showing some interesting products and some things that we're proud of, excited about, some things that are pretty cool technology. Today we're going to focus on a huge pain point in the industry, UL safety devices, photo eyes, safety edges, and wireless transmitter receiver kits for safety edges. My job today is to show you how simple it is with our products to wire up to 5 manufacturers' operators. We're going to be showing how to wire our products up to high security, Door King, maximum controls, LiftMaster, and All-O-Matic. Those are the 5 we're showing today. These are not the only operators we work with. We work with all of the major manufacturers. All of the devices that we're talking about today are UL certified or listed and labeled is the proper term. And so we're excited to show you that today. Again, I'm going to try to make this quick, about 20 minutes, and show you how to wire these up so that you can get in the job, install these, and get off the job as quick as possible. As you all know, with the new regulations, you have to have safety devices on the gate operators in order to make them even, open, or close. They have to be on there. So it's not an option anymore of if. It's an option. You have to do it. So let's learn the best practices to make sure that you can do this quickly, easily, and most importantly, that you're not getting called back to the job. We've been selling all of these products now for quite some time, and we have had huge success. They are extremely reliable and extremely cost effective. As always, we have Alex on the controls today, so please feel free to type in any questions you may have. He'll read them, and then I will try to answer them the best that I can. So, things that we're going to be going over today. We're going to show you all of the different options for photo eyes we have. We have reflective, wireless battery powered, and hardwired. Okay, 10K, normally closed, and pulsed. So we're going to cover the different variations. Just so you know, the manufacturers, all gate operator manufacturers are going to use at least one of the 3 technologies that I mentioned. 10K, which is monitored, which they all have to be monitored. That's why they're using these technologies. 10K, normally closed or pulsed. Pulsed is going to be your LiftMaster and your Nice. 10K is going to be Door King. Maximum Controls does 10K. Normally closed is going to be like high security. And then all of the manufacturers will tell you in their manuals what they are, but we're going to show you how to wire these up. So we're going to go over the different options of photo eyes that we have. We're going to go over our wireless transmitter receiver kit for safety edges, and then we're also going to go over and we'll talk a little bit about the actual edge, the edge that we have. If you have not tried these edges, you should. They're awesome. They can be cut to length in the field. There is no glue, so you get end caps. They can come pre-assembled, or you can just order a length with different end caps and assemble them in the field with no glue. Super easy to use, extremely reliable, and a really good product. Same with everything else we're going to show you, but big fan of our wireless transmitter receiver kit for safety edges. So what we're going to do is we're going to do something a little bit different. Usually we will wire up these devices to the machines that we have here. We're going to do it different. We thought it would be a little bit easier to watch and understand if we first show you the machine that we have, show you the inputs, and then we're going to show you the wiring diagram that's on our website, where you can find them, and then it's something very easy to look at. I recommend before you go to any job, if you're taking our safety devices out there, go to our website, print off the wiring diagram that is specific for the machine that you're going to be working on, whatever the manufacturer is, and it will save you a lot of time and a lot of headaches. So let's go ahead. And again, before I jump over, remember, feel free to stop and ask any questions. You can type them in, and Alex will see them and read them. Let's go ahead and jump over to the first machine. We're going to start with high security. High security is the first machine we're going to look at. You can see it is, like I said, we don't have anything wired to it right now. It's just a clean board. We thought that'd be a little bit easier to look at. Grab a screwdriver here. The big thing to keep in mind for all of these manufacturers as we're going through this is that if there are lights on, lights is a bad thing. If you have lights on, that means there's an issue for pretty much all of manufacturers. Some are different. But the wiring for high security is going to be the most complex, and I'll show you this in the wiring diagram here in just a minute. But we're going to be focusing on common on the board, the I common, the edge inputs, and the power inputs down here at the bottom. And so we're going to show you how that works. I'm also going to show you in the wiring diagram that there are controls. High security has some nice controls here at the bottom and then a display that we're going to have to go in and set the parameters for what you're going to have installed on this unit with the safety devices, either an edge and an eye, and what position it is, open or closed. So we're going to show you all of that for the high security line of products. So we'll go ahead and jump to the wiring diagram. You'll be able to see that on our website we have a whole section dedicated to the wiring, which we did this because we wanted to make your life easy. We know it can be frustrating when it's cold or hot and you're working on a new product or maybe a machine that you're not really familiar with. So we're at our website, transmittersolutions.com. I'm going to go ahead and click on our products. I'm going to scroll all the way to the bottom, and I'm going to go to UL 325 Solutions right here. At the very top in big bold red, it says UL wiring diagrams. And I've said this before, but we are always adding to this list. You can see right now we have All-O-Matic, Door King, High Security, Nice, LiftMaster, Buy-In, and Maximum Controls. We are always adding to this list. If you have a machine that you work on that you like to install, tell us. We'll buy one, we'll hook our stuff up, and we'll give you the exact wiring. Okay? So for this case, we're going to be talking about high security. That's the machine that we're working on right now. We have broken this down to just about as simple as it can be, and we want to make sure that it's simple. You can see that we're going to give you an image of the actual manufacturer's board, so in this case, high security. And then we're just going to go step by step of what you're going to do. So before you do any of the wiring, I would suggest setting your sensors in the high security smart DC controller with these steps that we've shown. So you're going to start at the main menu. You're going to press menu twice, and then you're going to hold the open and reset button, and then you're going to use next or previous to navigate the screen, and then you're going to select the sensors that you're going to do. High security makes it so that you select the sensor. Is it open? Is it a safety edge or a photo eye? Is it opened or closed? Open or closing, okay? You're going to set those, and then once you're set, you're going to get out of the menu, and now we're going to get to the wiring, okay? So again, like I said, high security is probably one of the more complex because we're using a ground on the board that is not used in any of the other manufacturers. It's just a little different. Once you figure it out, you'll be like, oh, this is easy. So what we've done is we've taken and we've broken this down into photo eyes and safety edge. Like you can see here, the top, we show eye open setup, eye closed setup, and the bottom edge open and edge close. Okay? So let's go ahead and walk through the eye open to start with. The eye open is it's going to be the same, the eye open and the eye close and the edge open and the edge close. It's just depending on how you've programmed it in the high security. So the first thing is high security is a normally closed technology that they're using. So we're going to use our NC from our photo eye, and we're going to go into one of the three sensor inputs that they have. You can see that they have sensor 1, sensor 3, and sensor 2. Depending on how you've configured your sensors in their control menu, like I've showed you before, is where you will program this. But for this diagram, we're going to show you eye open, we're plugging into sensor R normally closed into sensor 2. Then R relay common into sensor common. And we're also piggybacking our negative power into the sensor common, which you can see here with the black and green. And then our red positive power into our second terminal input. That's all you've got to do. And then that photo eye, once it has been configured to be an open photo eye in their control menu, is all set up. The only thing different you're going to do for the eye close is change what sensor you plug our normally closed into. That's the only thing that's going to change. And again, that is totally based off the programming that we showed you right up here in their menu. Okay? The edge is a little bit different. This is where I said we're going to use a couple different grounds on our board, the safety edge. So this is our iGaze RE kit. kit, the wireless safety edge transmitter. And you can see that the first thing I recommend doing is taking our positive power from our board right down here, okay, and going and putting a jumper between test 1, test 2, all tied into power, and those are going to tie into the 24 volts on the board. So that is something unique that you need to keep an eye on. Jumper test 1 and test 2, and wire those to positive on the iGaze RE board into the positive of the high security. Then you're going to take the sensor common from the high security into our test C. Again, something else that's a little bit unique. The sensor common, rather than going to our negative, is going to go to our test C. Then you're going to put our common 1 and our negative power both into one of the many commons on the board of the high security. If we can jump back to the high security board, you'll see that they have a whole bank right here of commons. You can use any of these commons. We just happen to choose this one right here because it's the first one there, okay? So you're going to wire that in, and then you're going to wire our normally closed into sensor 1, okay? And you're going to configure that through the menu. Now, the other thing to keep in mind is the dip switches. Our dip switches need to be set a certain way for what they're going to be outputting. You can see that the dip switch equals the color red. So for the transmitter, which you can see here, that 1, 2, and 3 are all on. And then for the receiver, the only thing that is on is dip switch 1. Everything else is off. Okay, and that's going to be extremely important when you're setting those up. Making sure, so you want to make sure your dip switches are correct and that you've got all your wiring accurate. And it's that easy. Then the high security board, when it's been configured through the menu and when it's wired like this, is going to be all good to go. The important thing is that we have this diagram available for you on our website. Print it off, take it with you to the job, or pull it up on your phone when you get out there, and then you're good to go. Any questions on the high security wiring? Okay, again, we started with the most complex. If you have any questions about that, write them in, and I'll move on, but you can still write them in. Okay, let's go ahead and jump to the Door King machine. Door King has their lights. They have a dip switch bank here that we're going to need to work with. Okay, so we want to keep that in mind, the dip switch bank that's here. This is their UL terminal, so we're going to want to pay attention to that. Can they see that okay? We'll raise it up just a bit. They've got their UL terminal, their dip switch bank here, and then their LED indicators are all right here. So that's what we're really going to want to pay attention to. We're going to be wiring here, setting dip switches here, and looking at our lights here to determine if there is a fault, where the fault is coming from. Okay? So we'll go ahead and jump to our wiring diagram. Again, this isn't the most exciting webinar that we've ever done, but it is something that we know causes a lot of frustration in the field. So I'm going to go ahead and jump to the Door King. Got a couple different options here. I'll actually go back and select the other one. Okay. So like I said, we pointed out the UL 325 terminal right there. We pointed out the dip switches here, and then you're going to pay attention to the LEDs over here. So what we've done is we've labeled all of the Door King stuff too. So you're looking at that board that we just showed you. First thing you want to do is set your dip switches. Dip switches must be turned on for each device wired to the terminal. So you have your open beam, your closed beam, your open edge, or your closed edge. So if you want it to work, you need to set the dip switch on. Okay? You're going to set your dip switches on, and then you're going to come down here, and we have open beam and closed beam for photo eye wiring. And then we're going to come down here for our open edge and closed edge wiring. Again, very basic. Zoom in on this. Okay, looks like we have someone that wants us to zoom in. Oh, okay. Is that better? So let's start with the open beam. And again, this is very easy. Now, one thing that you can just kind of ignore, and we will change this, is the 10K resistor that you see there is built onto the board of our photo eyes and our safety edge. UL requires that, and we're up to date with UL. So the UL, the 10K resistor, just ignore. You do not need to use that. It is built onto our board, okay? So let's start with the open beam. Again, we're looking at this terminal block that we're showing here is our UL 325 terminal block, which is the very, very top of the dorking board right here that we pointed out earlier. So all you're going to do is 4 wires. This one is very, very simple. Power, 24 volt DC power, right into our number 2 terminal, the red wire. The black wire is our negative power into the common on the dorking board. Then you're going to use our normally open. Even though dorking is 10K, our normally open is where we put our 10K resistor on our board. So you're going to wire normally open, ignore the 10K resistor because it's built onto the photo eye, into OB, open beam. And then you're going to turn dip switch 1 on because like we showed above, the dip switch 1 is open beam and it needs to be on. And then common is into their number 5 ground. And then you have your open beam. Moving over to the closed beam, all you're going to do is move the normally open over to the closed beam on the dorking and turn dip switch 2 on the dorking, and you're done. The photo eyes are extremely basic. Dorking has made it very, very easy, which is nice. Okay? And then we've got our open edge and close edge, and again, we're going to follow the same pattern that we just did with the photo eyes. We're going to go positive power into their positive of the dorking board, negative into the common, and those are found on the right-hand side. I'll actually show you. Those on the dorking board are located. We're getting power and ground over here on this terminal strip. Okay? That's where the positive and common are coming from to power up the unit, and then everything else is wired into here for their their UL 325 terminal strip. So that's what we're representing when we're showing the 1, 2, 3 common full open 24 volt DC. So after we do that, we're going to wire in normally open, again, because the 10K resistor is built onto this, into open edge, OE, and then common 1, the pink wire, into ground. Same thing as the photo eye, and again, always remember to turn your dip switch on. It's because we're using open edge. And the same thing for close edge, you're just going to move it to the CE, turn on dip switch 4 on the dorking board, and you're done. Extremely easy. Okay? Any questions on the dorking? Again, the whole point of this is just to show you, it's real. I know you guys have probably been really frustrated in the field using photo eyes and safety edges, or you're getting callbacks. We've tried to make it as simple as possible. We're trying to demonstrate that here. Any questions on the dorking? Okay. Let's go ahead and jump to the maximum controls. Okay. So something unique about maximum controls actually let you do, and I'll show you here, they actually let you have 10K or normally closed, which you can see here. So they've got their normally closed inputs here and their 10K inputs here. So you can use a normally closed UL sensor or a 10K UL sensor. And it's actually labeled UL sensor normally closed, UL sensor 10K. And you're going to set that up by a process that they have, but it's very, very easy, and you can use UL sensor normally closed or UL sensor 10K. So let's go ahead and jump to the wiring diagram here. And again, this one's pretty straightforward as well. We've tried that with all of these. Okay, so someone said they'd like us to put together something for a Viking. We can do that. G5 was specified. We'll get a wiring diagram for the Viking operator. Thank you. That's perfect. Okay, so you can see we have one big caveat here on primary secondary installs. The transmitter, or the TX, must be powered from a non-monitored source. Any power output on the Matrix 3, that's their board, other than the 12 volt DC supply on the UL sensor normally closed. So if you have 2 that you're doing through beam, you want to power it from a different source. Okay, so we've got a bunch of different devices here. They're all going to follow the same pattern. So this is our 66 HD, and you can see where we're wiring it in. We've drawn our lines directly from our transmitter and receiver. The 66 HD is a through beam photo eye, so both sides are wired, and you can see exactly what we've done. We're sharing power between them, and then the grounds on the transmitter and the receiver are going into the board, okay? And then we've got, sorry, I need to zoom out a little bit. Okay, I couldn't see everything that was going on. You can see that the ground is going into the ground on the normally closed. We're using normally closed on this. You can see it breaks off right here. Okay. The 50LR is another photo eye, so we've just taken those lines and kind of copied them. And then we're doing our normally closed into the open only, okay, which is a factory learned input. And then our everything else is done for that eye. Okay. The 50LR, you can see where we're going for the ground. And again, we're using the normally closed input for the 50LR. You can use normally closed. With our photo eyes, you can use normally closed or 10K. They will work on both technologies, so whatever manufacturer you're using. Normally closed is going into photo close, okay? And then common is going in with the ground. The edge, we decided to show you how to wire up the 10K, but again, it's very straightforward. We've done our first relay. Our edge has 2 relays. You can do 8 transmitters per relay. Excuse me. So we have the power going into their ground on the 10K side. And then we've got our positive going into the 12 volt DC. We've got our common going into the same ground, sharing that ground. And we've got normally open going into open. And then normally open 1 going into the 10K. And normally open 2 going into their close only, okay? So anytime you're using 10K, you're going to use our normally open input. And anytime you're using normally closed technology, you're going to use our normally closed technology. But again, a simple wiring diagram for the maximum controls board, which will see both normally closed and 10K, okay? And again, those are located right here, and they're clearly marked on the Matrix 3 board. 10K. UL sensors 10K, UL sensors normally closed. Green and blue. Blue and green, I should say. Okay? And again, one of the great things about our safety devices is all of the options that we have for photo eyes and safety edges are the same. We're still going to show you LiftMaster and All-O-Matic here real quick. But all of the safety devices we're showing you, I'll show you on our website here in just a minute, are the same. You can use them on normally closed. You can use them on 10K. Any machine using normally closed or 10K, you can use pretty much all of our devices. Now, when you're looking to do LiftMaster uses a pulse technology. So you'd have to order, we have a safety edge kit, wireless transmitter receiver that does pulsed, and we have photo eyes that do pulsed. And you can see this one there's pretty much no explanation needed. LiftMaster, their safety terminals are yellow. Yellow means safety for the LiftMaster. And all you're going to do is 2 wires. Positive into their eye open, or eye edge open or close, and negative into the common. It's that easy. It is literally 2 wires from the photo eye into the LiftMaster board, which you can see here. But when ordering, let me finish my thought and then we'll do a question. But when ordering, you need to make sure you specify to your sales rep you need the pulse technology because it's going on a LiftMaster. Okay, question.
So eye open, the gate will reopen, correct? And the eye close, gate will close?
No. So the question is eye open, the gate will reopen. Eye close, the edge will close. If we actually go back, I can show you. We've labeled it on our diagram here on the 4620. It says right here, open beam, obstructed opening, direction photo beam will stop at the gate during the open direction only. So if it's an open eye or open edge, when the gate is opening, if there's an obstruction, so it would be behind the gate, the trailing edge, the gate would stop, okay? And if it's in a closed beam, if there's an obstruction when the gate is closing, the beam will reverse back to the open position. So an open beam is on the trailing edge, and it will stop the gate so it doesn't hit something behind it. In some cases, it will reclose the gate. A closed beam is on the closing section on the leading edge of the gate, and it will reopen the gate so it doesn't hit something in the way, or stop it, depending on the manufacturer. Hopefully that answers the question. Okay? So again, LiftMaster, 2 wires, that's all you need, on their yellow terminals, or their UL terminal strip. And we have a pulsed kit for wireless transmitter receiver safety edge, and photo eyes as well that are very, very inexpensive, and they work really, really well. I've had a lot of success with them. Okay, so LiftMaster is pretty simple. Can everybody hear me? I think my mic might be a little, I'm good. Okay, I'm getting the A-okay. Okay, and then the last one we'll do is All-O-Matic. Again, same format here with the All-O-Matic board. We're going to scroll down here. We have an All-O-Matic, it's just in a different room. But again, very simple wiring for eye close and eye open to the All-O-Matic board. Again, it's all the same. It is all the same theory, right? You're going to use your positive power into the positive input. All these machines now have UL terminals that are going to be labeled UL terminal 10K, UL terminal normally closed, or UL 325 terminal, or eye open, edge open. They're all labeled pretty clearly, and they're going to be easy to find in their manual. So then you just have to say, okay, with Transmitter Solutions products, if it's normally closed technology, I know I'm usually going to use the normally open input. If it's 10K, I'm going to use, if it's normally closed technology, I'm going to use normally closed. If it's 10K, I'm going to use normally open on the transmitter stuff. And then you can always refer to these diagrams. So again, same thing for the All-O-Matic, positive power into their UL 325 strip positive, common sharing between the negative power and the common of the relay, and then you're going to use normally closed into their close or open eye input, which is labeled, they have it labeled MON close, MON open. Okay? And it's going to be the exact same setup for a safety edge. So those are the 5 machines we wanted to show you. Again, it's pretty basic, but it's only as being basic will help you with a lot of frustration in the future when you're out on jobs. So just real quick, just so you can see what we offer, I can promise you our photo eyes and safety edges are one of the least expensive on the market. Our actual safety edge is extremely good. You can see the different profiles that we have here. The wireless transmitter receiver kit, the iGaze RE for safety edges, will hold up to 16 transmitters, 8 per relay, and will work on any manufacturer that we've showed you today, plus any other. If it's 10K, normally closed or pulsed, which all of them are now because they have to be monitored, we have a solution for it for both wireless transmitter receiver kits for edges and all of our photo eyes. And you can see we have photo eyes ranging from reflective to through beam vandal resistant that are, if anybody has used our vandal resistant line, which is the HD line, you'll love it. It's really, really good. And pulsed for LiftMaster or any of the other technologies. So we wanted to be short and sweet. Hopefully that was helpful. Again, always refer to, and I'm going to show you where to go for wiring diagrams. From our homepage, click on our products, scroll down to UL 325 Solutions, and the UL wiring diagram is right here at the top. Okay? We will stick around for any questions you might have, but we really appreciate your time. Thank you.